Question 3, we are looking at mapping polynomials of degree 4, at most 4, to matrices 2 by 3 matrices. Now we're given two bases. Both of these are kind of the standard bases for their respective sets. We got the functions 1, x squared, x cubed, x to the 4, and we got the second, which is the basis, e11, e12, e22. This should be e11, e12, e13, e21, e22, e23. Okay, those nice standard bases. Now determine whether or not t is surjective. Well, the dimension of polynomials of degree at most 4 from R, this is 5, and the dimension of the 2 by 3 matrices, this is 2 times 3, which equals 6. Now, as the dimension of polynomials degree 4, at most 4, is less than the dimension of 2 by 3 matrices for R, T is not surjective. T does not land on every point. Okay, we know that simply by the dimensions. Remember, if the dimension of V is less than the dimension of W, this implies T is not surjective. If the dimension of V is greater than the dimension W, then T is not injective. Nice. Now, the next thing they asked us to do is give a matrix for T. So to do this, we want to see what T does to 1, T does to 2, T does to 3, T does to 4, or sorry, not 1, 2, 3, 4. T does to x, T does to x squared, T does to x cubed, T does x4. And here, what's happening is my function is a x4, b x3, c x2, d x1, e. So really what this is e equals 1, d equals 1, c equals 1, b equals 1, a equals 1, and the other coefficients are 0. So when I look at this matrix, everything except for e, I put a 0 by. So 0, 0, e is 1, 0, 1, 0. And now, all the ones that are 0, this becomes 0, e11 plus 0, e12 plus 1, e13 plus 0, e21 plus 1, e22 plus 0, e23. Here, my next piece, d being 1, this becomes 0, 0, 0, 0, oh, sorry, 1, 0, 0, or 0, e11 plus 0, e12 plus 0, e13 plus 1, e21 plus 0, e22 plus 0, e33. C being 1 gives us 0, 1, 0, 0, 0, 0, which gives us 0, e11 plus 0, e1, 2, or sorry, 1, e12 plus 0, e13 plus 0, e21 plus 0, e22 plus 0, e23. B equaling 1 gives us 1, 0, 0, 0, 0, 1, or 1, e11 plus 0 plus 0 plus 0 plus 0 plus 1. And then a equaling 1 is 1, 1, 0, 1, 1, 0. So it's 1e11 plus 0 plus, or sorry, 1 plus 1 plus 0 plus 1 plus 1 plus 0. So my t alpha beta is going to equal, the first column is 0, 0, 1, 0, 1, 0. Second column is 0, 0, 0, 1, 0, 0. Third column is 0, 1, 0, 0, 0, 0. Fourth column is 1, 0, 0, 0, 0, 1. And fifth column is 1, 1, 0, 1, 1, 0. We have our matrix representation. Okay. Now what we need to do is we need to create a basis for the image. And we have a proposition that is nice. If we consider the system of equations T alpha beta V alpha equals 0 in beta, the vectors corresponding to the free variables form, or sorry, the basic variables form a basis for the image of T. So what I'm going to do is I'm going to take this matrix, I'm going to set it equal to 0, and I'm going to figure out what vectors, which scalars here are my basic variables. So if I take this matrix, I'm just going to copy it down. So and because I've got a computer, I'm going to copy it nicely. Control C, Control V, Control V. I'm going to copy it nicely, bring it down. So we've got this matrix. Okay. I'm going to augment it with the set 0, 0, 0, 0, 0, 0. And what we're looking for is we're looking for the basic variables. So first thing that I'm going to do is I'm going to take row 3 and swap it with row 1 to give me 1, zeros everywhere with a 0. And the second row is the same, 0, 0, 1, 0, 1. Third row is 0, 0, 0, 1, 1. Fourth row is 0, 1, 0, 0, 1. Fifth row is 1, 0, 0, 0, 1. And sixth row is 0, 0, 0, 1, 0. And now what I'm going to do is I'm going to do row 4 minus row 1, or row 5, sorry. Minus row 1 replaces row 5. So 1, zeros everywhere else. 0, 0, 0, 1, 0, 0. 0, 0, 0, 1, 0. 0, 1, 0, 0, 1, 0. And now here this becomes 0, 0, 0, 1. And finally I have 0, 0, 0, 1, 0. Now I could be clever and I could see that this row and this row are the same, and I could subtract them. But I'm just going to follow the elimination algorithm. So now I'm going to swap row 2 and row, find the pivot. Here it is, the one there. I'm going to make it, put it in the right spot. So I'm going to take row 2 and row 4, and I'm going to swap them. This gives me 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, and now 0, 0, 0, 0, 1, 0, and finally 0, 0, 0, 1, 0. Okay. That row's columned out. So now I find my next pivot, which is in row 4. I'm going to move it to row 3 by taking row 3 and swapping it with row 4. 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0. 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1, 0, 0. We look at the column. You know, look, it's zeroed out. Next one, there's my pivot. I need to zero out the column. It is 1. It's in the right spot. I need to zero out the column. So I need to make that column 0 everywhere. So I need to take R6 minus R4. This is R6 to give me 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0. Oh, I forgot this one is supposed to be a Z. This one is supposed to be a. Oh, this here is supposed to be a 1. Then I get 0, 0, 0, 0, 1, and 0, 0, 0, 0, 0. And finally, I need to zero out this column's in the right spot. I need to zero it out. So R2 minus R5, replacing R2 gives 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, or 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0. My basic variables are, if I convert this to a system of equations, it would be x1 equals 0, x2 equals 0, x3 equals 0, x4 equals 0, x5 equals 0, my basic variables, and then 0 equals 0. My basic variables are x1 through x5, or all vectors. Okay, so these are all of my vectors. They're all basic vectors. So my basis for this is going to be the output of all of these outputs. They're all going to be basis vectors. Well, now I have to scroll up to see what those basis vectors are. And I can take these matrices up here. These matrices give me my output vectors. So my basis is going to be the first matrix, which is 0, 0, 1, 0, 1, 0. Because that's my first output. My second is going to be, this is from x1. The second one is going to be 0, 0, 0, 1, 0, 0. The third's going to be 0, 1, and then zeros. The fourth is going to be ones on the beginning and the end. 1, 0, 0, 0, 0, 1. And the final one is going to be ones, then zeros in a block. So 1, 1, 1, 1, 0, 0. And that is my basis. Now, because once I have a basis, I can use rank nullity. The basis tells me the dimension of the image. The dimension of the image equals 5. The dimension of polynomials of degree at most 4 real numbers equals 5. The dimension of the image, and this is the image of t. Dimension of the image of t plus the dimension of the kernel of t equals the dimension of the polynomials at most degree 4. So kernel, or the dimension of the kernel of t equals 5 minus 5, which equals 0. This implies that t is injective. We could go back here and we could say, hey, the only solution vector is the 0 vector, therefore we're injective. But here, we don't need that. All we need is the dimension of the basis. And we can use the fact that we know what the dimension of polynomials of degree 4 is in order to show that t is injective.